This is Unit 5, Lesson 3, angle, side angle, and angle, angle, side. These are two more shortcuts to prove triangles congruent. The first says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. This gets down to the root of the idea of included versus non-included. If you notice in the diagram, the side is between both marked angles. So your double angle, side, then your single. So if you can show that you have a side, an angle, an included side, and a second angle congruent in the other triangle, then you can prove triangles are congruent. The other one is called angle, angle, side. Two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. The difference in these shortcuts is the idea of included versus non-included. If you notice in the first one, the side was literally between the two angles. In the second theorem, the side is not. So I have a single. Over here I have the double angle, the single angle, and the side. To be included would need to be here in the green. It's not there, it's on the other side, so it is not included. Which two triangles are congruent by the side, angle, side theorem? I'm thinking angle, side, angle. So we're looking for an angle, an included side, and an angle. Well, I see that the side length CA is included between angle C and angle A. DG is included between G and D. But NF, even though it's marked congruent, it's not between the two. So the two that are congruent by angle, side, angle are these two. A congruent statement, triangle, and you can write these in different orders as long as whatever order you choose for the first is the same as the second. I chose C, T, A, so mine's going to have to be G, O, D. Are these triangles congruent? Justify your answer using two if-then statements. All right, so it looks like we have two angles and we have a side. So I'm going to say yes, they're congruent using angle, angle, and that side is not included. So my if-then statement, if two angles and a non-included side are congruent of not perfect, but I took the theorem and made an if-then statement. If two angles and a non-included side of one triangle are congruent to another, then the triangles are congruent. The second if-then statement comes from actually finding another theorem to prove these congruent. One of the first lessons, I think it was lesson 1, said that if you know that two angles are congruent, you can prove the third is congruent. So since I know that angle O and H are congruent and angle L and angle F are congruent, then angle G has to be the same as angle Y. And just look at this for a second, and I'm going to kind of make up these values. But if this value is 110, this would be 110. If this one is going to be 30, then this one would have to be 30. That gives me a total of 140, so then that would have to be 40 to equal 180. I don't necessarily know the measures, but whatever they are, the third angle would have to be the same. So if you think about this third angle, oops, where'd my side go? I think this side was marked originally. If you look at the third angle, using this information down here, I've now created same triangles can be proved using angle, side, angle. Next page, use the given information to show that the triangles are congruent. So these are written and laid out as if you were going to do a proof. We're going to do it very informally, but everything can still be marked. So given, you're going to have to mark everything. So given that angle BAC is congruent to angle DAC. So they gave me that information. So I marked it here in red. The other one says that AC is perpendicular to BD. Well, when you're perpendicular, it creates 90-degree angles. So that's marked there in green. Can anything else be assumed in the triangle? Well, AC, it butts up against itself to AC, so I know that those are congruent based on the reflexive property. So it looks like I have an angle, an included side, and a second angle. The next problem, it's telling me that QR is congruent to TS. Then it's telling me that QR is parallel. So the little arrows are meant for parallel. Well, what does it mean to be parallel? If we were to use QT as the transversal, that means that those two angles can be marked congruent. Because we know if lines are parallel, then alternate interior angles are congruent. Is anything else congruent? Again, QT, just like AC, matches up to itself, so those are reflexive. So I have a side, I have an included angle, and another side. So these are congruent by side, angle, side. Error analysis. A friend conjectures that there should be an AAA congruence postulate since there is a side-side-side congruence postulate. Give a counterexample to disprove your friend's conjecture. We did this already in regards to the exploration. So this is a made-up postulate. It doesn't actually exist. This is the conjecture. Why does this not happen? We talked about it in class that angle, angle, angle doesn't happen because as we were constructing triangles, angle, angle, angle does not work because as we were constructing triangles, we could slide these, sorry for all the sounds, we could line up A, B, and C to any width. So I'm choosing to put A, choosing to put B here. But it could be anywhere in here, and I could make a tiny triangle, or I could spread it way out and make a large triangle, and C would still fit up there. So angle, angle, angle doesn't work because there's no side to kind of lock everything into place. So I'm choosing to put B there, but if I put B down here, it would just make a smaller triangle. So anything that you could write down, angle, angle, angle doesn't work because the side lengths could be different. Which is shown in the example here with triangle DEF and triangle ABC. So just to make it clear one more time, angle, angle, angle is not, because three angles is not enough to determine that they're congruent, only that their angles are similar. It says nothing about their side lengths. Anything extra, feel free to jot it down here, but that concludes lesson 3 of Unit 5.